Yo, what up? It's Jeff. Welcome back. In this video, we're going to take a look at solderless breadboards. Specifically, we're going to see how these things can be used to make electrical connections between components. These will be the main tool that we use to connect our resistors and use jumper cables as well as the voltage and current sources. Some things that should be said about the solderless breadboard. We're going to think about this as the regular position that we're going to want. Specifically, we see that the columns are labeled with the letters A, B, C, D, E, F, all the way to J. And that is 10 columns. 1, 2, 3, 4, 5. We've got this center divider where there's no connections here. And then we've got another 5 columns, so a total of 10 columns. Down the left and right hand side, we see that there are numbers 1, 2, 3, all the way to 30. Same thing over here. We see a repeat of the column labels. Here we're going to call these column labels, we'll call the numbers row labels. The space in the center we'll call the center divider. When it is in the standard position, we're going to call this section over here the left power rail. That's because we're going to connect, in some situations, power to that rail. Given that this one on the left side of this is called the left power rail, could you guess what we call the one over here? Ding, 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 ding. You got it. That's called the right power rail. Each individual hole on this entire breadboard has its own addressing system. This breadboard is 2.2 inches wide and 3.3 inches long. The holes here, if we look at the main section of the breadboard, I guess I should be a little bit careful and discuss what I mean by this. The holes that are actually labeled with letters and numbers, we're going to call this portion the main section. Notice that there are 300 points, 300 places that you can connect components because we have 10 columns and 30 rows. 10 times 30 is 300. That's the main section. In the power rails, notice that we have 5, 10, 15, 20, 25 times 1, 2, 3, 4. So there's a total of 100 points in the power rails, 300 in the main section, and that's why we call this a 400 point breadboard. We can talk about the addressing. Notice in breadboarding, this kind of makes me really frustrated as a linear algebraist, because in linear algebra we always say that the row comes first and the column comes second when we're addressing. In breadboarding, we usually name the column first and the row second. Really frustrating. I would appreciate it if we could switch that, but I won't argue with electrical engineers. For example, let's talk about that hole or that point right there. Notice that is in column C and row 11, so we'd call that one C11. Down here, let's say that we're going to go J27 because it's in column J, row 27. For our purposes, I will actually name the different vias. VIA is another way to say hole, so the different like little things that we can put the components into on the power rail. So we're going to call this left power rail positive, so we'll call that left power rail LPRP. LPRP 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 15, 20, 25. So if I wanted LPRP 7, left power rail positive 7, 5, 6, 7, right there. Let's say that I want LPRN, left power rail negative 16. Well, left power rail negative, I go to the left 16 because I've got 5, 10, 15, 16. Let's say that I wanted RPR P4. Right power rail, positive 4. Must be that one. The really kind of interesting thing about here is, about this breadboard, the solderless breadboard, is that the connective points on the main section come in groups of 5. In particular, if I look at 1, 2, 3, 4, 5, so A1, B1, C1, D1, E1, those are all electrically connected by conductors. Same thing can be said about everything in the row to the right of the center divider. So if I look at F18, G18, H18, I18, and J18, those 5 points right there are electrically connected by the same conductor. The center divider allows me to know, like in this main section, these are not connected. So in the main section, connections come in groups of 5. On the power rails, the entire set of left power rail positive is connected. That is not connected to the entire set of left power rail negative. Same thing, in the power rails on this small 400-point breadboard, these connection comes in groups of 25. Now, I would really like to ask, well, why is that the case? Why do they come in groups of 5 on the main section and groups of 25 in the power rails? Well, in order to answer that question, let's go ahead and do something extremely fun, which is to take stuff apart. It's one of the most fun things that we can do in life. Take stuff apart and see how they work. On the back of this, they come with an adhesive little sticky thing, and this is so that electrical engineers that are building with lots of breadboards can stick them on and they won't fall apart. In our case, we're not actually going to need this, so we can take the backside off. Notice once we do that, we can actually deattach the power rails from the main section. One thing that I should note is that there's a kind of a cool situation that happens in breadboards where we have tabs and slots. That allows me to connect and disconnect components of the breadboard that I might want to use quite easily. If I had multiple breadboards together, I could connect the tabs and the slots and create a much, much larger working surface. And this is useful for large electrical engineering builds. In the back of this thing, we're actually going to look at 2 separate components. We're going to look at what we call the plastic casing and then also the contact strips. Here I have a kind of a really, really fine Phillips screwdriver that I'm going to use to kind of disconnect the contact strips and then take these out. Check this out. This is a single piece of metal that has like almost like a spring-loaded mechanism that I can put components into. We're going to take a look at how this works. So let's suppose that we're going to connect some resistors to this breadboard. So here we go. When I put the end of these resistors, when I put this end into the vias, what I'm doing is I'm actually piercing the electrical or the plastic component and putting it into the contact strip. So check this out. Do you notice how that goes all the way through? Well, the reason that it goes all the way through is because I've taken out that contact strip. If this was in, the end of the resistor would go very nicely into one of those 5 little spring-loaded sections. And then the moment that that happens, we can think about the metal part of the resistor as the same actual component, electrically speaking, as the metal contact strip inside the solderless breadboard. And that is because these are designed in such a way that they allow electrons to flow. They allow current to flow really, really easily with minimal resistance. The reason that we say that the electrical components in a breadboard comes in section 5 is because these contact strips are designed to come in sections of 5. The plastic casing just gives us a really nice addressing scheme. It allows us to name which point has which particular address. When we said that the power rails come in electrical connections based on 25, that's because the actual contact strips in the power rails, if I take this thing out, this is always a little bit kind of interesting. Please do not do this unless you specifically ask your professor's permission. I'm doing this as a way to demonstrate this to you, but if you're in lab and you're like breaking these things, I can tell you everything that you see I purchased out of my pocket, and I plan to use those with my students. I would be a little bit sad because my kid's college account is a little bit less full, and then I would hate it for people to just like muck around with these things. Okay, so that's enough on me being cheap. The reason that these come in sections of 25 is because they're literally 1, 2, 3, 4, 5 of those groups of 5 contact strips And then they're connected by little metal wires. So it's like one piece. You can kind of see how I'm like wiggling that around a little bit, right? So when I put the end of my resistor through that plastic casing, it actually goes down into that contact strip. So it's kind of hard to see this. This is not the best camera that I've ever worked with, but you see that? How I can kind of just put that into that spring-loaded section, and the moment that I do that, the metal is touching, which means that one piece of wire now is extended by the entire metal strip. And this would mean if I attach something down on this side, these two resistors are now connected electronically. So we think about that whole piece of metal as one single conductor, and then here we've got a resistor, and there we've got a resistor. With that said, that's kind of why we talk about these. They're not even rules, to be honest with you. They're just kind of features of the design of the breadboard. This is kind of hard to get in, so I might do that later. I don't want to waste your time with that. Okay, so with this said, we can reconstruct the entire breadboard. And then this is where we can get really, really precise. So let's say that I wanted to connect a resistor from A2 all the way over to like F2. One side of the resistor goes into A2, the other one goes into F2. This entire part of the resistor is now connected along each of those inlets. So this would be B2, C2, D2, and E2. Those all are electrically connected to this component because of the way that contact strip works. Similarly over here, when I put this into F2, G2, H2, I2, and J2, those points right there connect me electrically to that metal part of the resistor. Thus, when I go ahead and connect J2 with the resistor all the way down to, let's say, J10, this metal component is actually electrically connected to this metal component through the contact strip inside that part of the breadboard. And then here we've got that resistor, single piece of metal that runs. We've got another resistor, single piece of metal that runs all the way down to here. And that's how I can create connections between many, many different components. The nice thing about the addressing system is it allows me to do it really precisely. We're going to leverage this technology and make connections between what we call an ideal circuit diagram. An ideal circuit diagram is how we design circuits, or how electrical engineers design circuits. And then the wiring diagram is how we actually turn the ideal model into an actual circuit that we can build with our hands. Breadboards are really, really useful for the wiring diagrams. They allow us to make a one-to-one connection between how we connect components. Major picture, the whole idea is we're going to use linear algebra to model this process. Amazing. Absolutely amazing. I'll see you in the next video where we actually do our first circuit build. Peace.